So this is quite a good example of a site we did down on the River Medway, and the water level is normally about 4.5 metres deep. So it was impossible to dry it out to install a GoFlo system. So everything had to be designed so it could be bolted to the existing structure and then assembled on site without interfering with operation. So what you're seeing on the screen at the moment is a model of the actual concrete structure. We got a dive survey in, and the divers actually went into the water to measure everything up. This is the fixing frame that's designed to fit precisely to the profile of the concrete as it actually is. And this was lowered into position using a crane, and then divers drilled all the fixings. Then the frame was actually lifted out to be assembled into what we call the intake box, and then reloaded back in and fixed in position. So this picture shows the intake box sides that have been assembled onto that fixing frame above water. The intake box was assembled on site, and then the GoFlo system was bolted to this intake box. All the fixings you can see on the bottom aligned precisely with the base plates of the GoFlo screens. And we actually designed a special gauge so divers in zero visibility could slide this sort of special tool we made into a gap, and then they could easily read off what the actual gap was and then just radio that back to the surface. This shows the intake with the actual GoFlo screen lifted into position into the intake box. Because they have integral guide rails, the screens could just be lifted in vertically, one at a time, attached to the guide rails and just slid into the water. So there's no need to have divers at the bottom guiding anything in. Once they're on the guide rails, it'll accurately just slot in and locate itself at the bottom onto its base plate. And this was particularly important in this project because these screens are 6.1 metres long and weigh something like 1.4 tonnes each one. And they've been lifted into a water level that's 4.5 metres deep with zero visibility in a working intake. But it worked really well, and the actual screens, from lifting off the back of the lorry to being in the intake, both screens probably took about 4 hours. So again, it just shows the benefit of that 3D design and getting that model right at the early design stage. So again, now this shows the coarse bar screen that's been lifted onto the front of the intake box and bolted into position. Again, this slid down slots and was just bolted at the top just to make it quite simple to install. And this is just to keep any really large logs and also people out of the intake, because people do swim up and down the River Medway. And this shows the walkway and all the handrails that were designed. Again, this was all fabricated back into the workshop and pre-assembled just to make sure everything fitted properly. So when it turned up on site, it could be just lifted in sections, everything aligned perfectly, bolted up. Same with the handrails, that's all compliant with the particular water company's regulations. Then this shows the debris trough added onto the back of the screens. As the debris falls off the top of the screens and the spray boom blows any remaining debris off, it all gets captured into a trough, which has a pump flow of water into it as well, which carries the water down the trough and just returns it back into the river downstream of the intake point. Again, it just shows the power of that 3D model to get everything precisely right, even to the point like the pipe work, where we have water connecting onto the debris trough. We can show exactly where that will be so that the main contractor can make sure that their supply water pipe work will bolt onto the flange that we provide. In total, the actual works on site took about 2.5 months to build. They were up against a particularly tight deadline to meet a regulatory date to meet eel regulations compliance, but they achieved that. The manufacturing process, it really starts once that collaborative design stage is finished. I mean, the aim of the earlier stage is to get that 3D model built for the design that everybody's happy with and everything fits absolutely perfectly together, because then we'll turn that design into something that's going to be laser profiled and folded using CNC machines, and that goes to the fabricator we work with. It all is welded together and it goes to our workshop for assembly. So what we build into that 3D model will be exactly what we deliver to site. And we've got a very good reputation for things fitting together very well and looking very nice on site. That's because we've got the 3D model correct to start with. So yeah, once it's fixed, the design, it's certainly not an automated process. There's a massive amount of work goes into it, but by getting that electronic model correct, it's quite amazing. But it does produce exactly what the design model said it was meant to be. So.